Hello, Internet. So, I feel like, this is like a really cool topic. C compiler in one file, right? And it's a real it's a real C compiler. I can compile, I've compiled Doom, Lua, FreeType, a Game Boy emulator, zlib, I can compile real projects with this C compiler that fits in one file with no dependencies, right? So, yeah, it's written in JavaScript. There's a C++ version I'll get to eventually. But similar to Clang or GCC, whatever you're used to, but there are three different types of files you can generate. At its core, the compiler produces WebAssembly files, WASM files. But because a WASM file requires runtime to run, for convenience, the compiler can also generate JavaScript files that will run on Node.js and HTML files that will run in the browser. But basically, you can give it any C project and set of C sources, and you can just dump it and run it. So technically, the compiler itself for generating the WASM file is just one file. The compiler is one file, right? But to actually run the binary that you produce, there are up to two more files. Hear me out. So host.js is the runtime that's required. Without it, WebAssembly itself cannot communicate, read files, print to screen, draw stuff on the screen. It doesn't have any of that. So host.js, which is also portable, by the way, it works both on, it adapts to whether you're on Node.js or in the browser. And that file needs to be present right next to compiler.js if you are creating either. Right. Okay, so I want to get into the details of what it is. It really is a single file, right? This is it. It's got a parser section. It's got a Lexer and preprocessor. It belongs in one section. Above that, there's a codegen section that will take the AST produced by the parser and turn it directly into WebAssembly. And then there's a standard library section that actually contains an embedded miniature libc. So you don't need to bring your own little libc and have that headache. All of that is included in the single file compiler, which I don't know. I personally think this is something I've always wanted. I always thought it was such a headache. Oh, I would like to learn how Clang works, and then it's just this whole thing, giant build system, whatever. Yeah, I don't know. I mean, yeah, you got TinyCC, you've got ChibiCC, which are also cool, but come on, one file, and it's easier to take your JavaScript file and run it in an iPhone, right, than it is to run a collection of C files. Anyway, yeah, and when I say no dependencies, I mean it. There's no package.json. There's nothing to install. You can run it on Node, and it will require fs and path to look up the files. But if you want to just inject the files directly, the C sources directly, and run it from the browser, it also works fine that way as well. So it really is a truly portable JavaScript single file C compiler with no dependencies. I mean, come on. And yeah, built-in preprocessor. I've seen so many small C compilers that say, oh yeah, learn how to write and I've seen these blog posts trying to teach you how to write a C compiler, and then they decide that writing the preprocessor is not going to be part of the process. I don't know. I think it should be. Yeah, I agree. The preprocessor for C is quite annoying to do. But I also think, if it's a little disingenuous to say you have a C compiler without a preprocessor. I don't know. Just my 2 cents. And then it does emit raw WASM files. It's not I don't emit assembly and say, well, let the assembler do the rest of it. No. I take it all the way. My compiler, my single file C compiler will produce raw WebAssembly files. Okay, yeah, I mean, right. And then, yeah, so what exactly is covered here? It's a little bit more than this, actually. So almost all of C99 I've tried to cover. and then a good chunk of C11, and then some minimal set of SCL bindings to be able to do fun graphical demos. Yeah, so I have my own little Cloud Code wrapper. Doesn't everybody have a Cloud Code wrapper nowadays? Anyway, so I asked my little Cloud Code wrapper, how thoroughly does a C compiler cover C99? Maybe I'll add it at some point. VLAs, I also decided not to add VLAs. Not as universally used. Quite a headache to implement, so didn't add those. So like, yeah, mostly, you know, and then yeah, quite a bit of like C11 as well, but not quite everything, right? Yeah, and then again, it runs in both Node.js and in the browser. Yeah, so there's also compiler.cc. So you might kind of wonder, like, why did I write it in JavaScript to begin with? Actually, like, the kind of my original desire was to have a C compiler. Like, wouldn't that be the most beautiful thing? I still think there is room for improvement here, right? Like, I think the most beautiful thing would be a single file C compiler, right? That compiles to a single file C compiler that, like, no other dependencies except for the standard library, and then, you know, it just works. Yeah, so, but I did it actually. So I decided to use C++20 instead, and then my original plan was actually to use C++ features, get it complete, have a set of tests, and then piece by piece, like, migrate those C++ features down to C. But even that turned out to be quite a pain to do. So instead, I decided to port it into JavaScript instead, which I realized, like, it's actually much more fun. It's actually much more fun to do that. So that's what I did. Instead of, my original plan was to port the C++ version into C, down to C, but instead I ended up porting the C++ version directly to JavaScript, and I realized, like, it just is more fun to extend it in JavaScript. So, like, if you want to see what it looks like if you want to build something a little bit more complicated, it kind of, like, breaks a Unix philosophy in that, like, it kind of does a lot of things, but, like, it's kind of as simple as it can be, right, to build a project like this. So yeah, you need to provide all the C sources for the Doom itself. Doom requires some sort of, like, Doom requires the audio card to be simulated in order to play audio. So there's, I got a library for that there. Include path, and then bundle some files. Like, this is a feature that you will typically not see in most other compilers. See, it's got even features that even other like real compilers will not include, right? Like, if you want to bundle, data files inside your executable, there you go, right? Anyway, so OPFS is kind of like the virtual file system on the browser, and this flag will copy this file here and then put this in the virtual file system. Put this file into this path in the virtual file system. You can also specify certain command line arguments that will be passed when the program starts inside the HTML, and then also the final, build doom.html, right? Like what you want the HTML file name to be, right? So like, that makes sense, but it's a little bit tedious, right? So the compiler for all the flags. So you say, like, for building it, there's a JSON file that specifies all the flags that are required to build this project, and then all you need to do after that is just specify, okay, I want this to be dumped out to this file, right? And yeah, so this is kind of also what it looks like. Pretty self-explanatory, right? I mean, I feel like this is kind of what I want. Like, this is just what I want the C ecosystem to look like. You just have a JSON file with, like, the compiler args, the data file you want bundled, bunch of C sources, and then yeah, and then it works. So yeah, like, I think like, there are actually, like, I guess I'm kind of glossing over the fact that there are quite a lot of interesting, like, challenges to targeting the WebAssembly platform. like you might wonder like, hey, so if you actually are familiar with WebAssembly, you might be aware that arbitrary go-tos and labels are not supported in WebAssembly. All jumps have to be structured. So technically speaking, absolute arbitrary go-tos are not supported in my compiler. However, like it turns out the vast majority of real C projects, they do use go-tos, but they actually use their use of go-tos are actually quite structured. So all these other projects I've compiled, I've been able to get away with like using a few heuristics and using that to implement the go-tos. Technically speaking, like in theory, you could implement any kind of go-tos using some sort of state machine. I've decided to avoid doing that because that actually would be quite a big like thing to add to a single file C compiler, to be honest. But yeah, I don't know. I think there's even more room for improvement here with the go-to stuff, because I think you could still add like, in my head, I feel like there are a few more heuristics for some cases. The other even crazier thing using WebAssembly, because the way that you would normally implement long jumps in a real platform involves like like unwinding the stack, right, manually and figuring out, okay, I need to have this point in the stack, this set of state needs to be stored somewhere, and then you need to restore that state and arrive, at the set jump location. It turns out like most uses of long jump also that I found are basically like try catch, right? Like they basically work like try. So technically speaking, also, not all possible long jumps are implemented in my language as well. But in practice, because like the way people use long jumps are to make up for the fact that there is no throw catch, the use patterns actually follow what you would expect with a throw catch, right? So you could actually swap them out for a throw catch, which is what I actually do. So WebAssembly does natively support exceptions and exception handling. So I actually have special keywords starting with the double underscores for exception and throw. And when I see set jump and long jump, I actually have the compiler hack those in and modify the AST so that they actually turn into throw catch. Which I don't know, like it sounds it's a little bit easier than that it sounds, but it is still a little bit hairy. But it allows me to like compile stuff like Lua and a couple other things without any modifications to the source. The other thing is like how do you deal with local variables? Like because in C you need to be able to get pointers to any variable, right? Like you can have a local variable somewhere. It's like a common pattern to have, say, a local variable int and then scanf for that variable. Scanf to fill that variable. But luckily, I mean, like I guess this one is pretty self-explanatory. The go-tos and long jumps are the crazy ones. Local variables, you might think I would have everything in linear memory, but it turns out actually it's not too hard to just have that be detected. Anyway, so this is getting kind of long. I think like in the future videos I might cover, how I feel like it's a cool project. I just wanted to share it. I don't know. I don't know. I just wish I had more people to share this kind of thing with, because I personally, like when I tell people I have a single file, a C compiler in a single file, people just go like, oh, okay. But like, it gets me very excited. I don't know if that's true for other people. But yeah.